Hello everyone, my name is Gano Kim and this is my project design plan presentation for CEN 3031. The title of my project is Silent Signal School Safety Bot. So here's what I'll be covering in this presentation. First, in part 1, I'll walk through an overview of the project and explain the roles involved, the core problem we are solving, the tools I chose, and how the system is designed. In part 2, I'll present some key user stories, share the product backlog along with planning estimates, and walk through the Sprint 1 plan. Lastly, in part 3, I'll discuss current challenges and the next steps in the development process. Let's begin by understanding the foundation of the project. This project is called Silent Signal and is an open source tool designed to improve emotional safeties in schools using conversational AI. It's a solo project, which means I'm working under the team name on Whisperline Group 14 all over by myself, and I'm handling all parts of the development by myself. That includes project management, front-end and back-end coding, machine learning integration, and testing. What problem am I trying to solve? Many students experience bullying, stress, or emotional challenges, but they often don't report these issues. The response can include fear on retaliation, lack of trust in school staff, or simply not knowing how to ask for help. As a result, schools may not become aware of issues until it's too late. To address this gap, I am proposing a web-based chatbot that students can access easily and use anonymously. Through casual conversation, students can vent or share their feelings. The chatbot can analyze these messages in the background using GPT to detect signs of emotional risk. If something concerning is found, the system can alert school safety teams through a private dashboard. This helps schools catch early warning signs while giving students a safe and judgment-free way to be heard. Now let me talk about what technologies I'm using to build this. On the front end, I'm using JavaScript with React to build a chatbot uh, interface. The backend is built with Java and Spring Boot, which handles communication with the AI model. For detecting emotional signals, I'm using the ChatGPT API. And for organization, I use GitHub projects to manage tasks and Figma from simple UI designs. Here's how the system is structured. A chatbot interface is built with React, and it connects to a backend built in Spring Boot. When a student sends a message, it gets sent to the backend, which passes it to the GPT API for analysis. The API checks the message for signs or distress and returns a score based on the risk level. This forms the core interaction in the system. Building on that, the system also includes a database to store risk stores and alerts. After the GPT API processes a message, the backend stores the result in the database. This information is then shows on the admin dashboard where school staff can review risk patterns and take action if needed. Next, let's move into planning the actual project. To better design the system around real needs, I created several user stories. The first one is from the student's perspective. As a student, I want to walk anonymously about my feelings without fear. This emphasized the importance of emotional safety and privacy. Another user story is for school staff. As a staff member, I want to be alerted if any chat looks dangerous. This ensures that schools can act on potential problems. Finally, for administrators, as an admin, I want to see weekly risk trends in one place. This helps track overall patterns, such as whether certain weeks or events trigger higher emotional distress. These stories can guided how I shape the features, especially around uh, anonymity detection and reporting. Here's a breakdown of the main features I plan to build. First is the chatbot interface. It allows real-time messaging between students and the bot. Next is the anonymous mode, which lets students use the bot without logging in, protecting their identity. The GPT-based risk scoring analysis messages and flags them if concerning patterns are detected. The admin dashboard visualizes alerts and trends so staffs can review flagged chats. If the GPT API goes down or hits a usage limit, failback logic and with basic keyword rules will ensure the system still works. Lastly, an optional login system which allows students to view past conversations if they choose to sign in. Each features has been broken down and assigned story points based on complexity. For Sprint 1, I wanted to focus on the core of the chatbot experience. This includes building the front-end interface where students can type messages, connecting that to the backend, and the integration the GPT API to analyze those messages. I also included basic anonymous mode functionality so the students can start chatting without an account. These tasks together total around the 10 story points, which I believe is an achievement with a 1 week solo sprint. I plan to test this functionality and do it so that by the end of sprint 1, I'll already have a working prototype of the conversation flow and detection logic. Now let's talk about what challenges I faced and what's next. There are three main challenges I have identified. First, GPT API reliability and cost. First, I need to make sure the system can handle failures or limits. Second, the time management. Since I'm working solo, staying on track is critical. And third, I haven't yet tested the project with real students or educators. For next steps, I plan to prepare the first demo version soon, get peer feedback, and expand the admin dashboard in Sprint 2. You can follow updates and the repo at the GitHub link on the screen. Thank you so much for listening to my presentation.